Hello math students. Today we are going to learn how to calculate percent change and percent error. We'll start by looking at percent change first. Percent change can either be looked at as a percent of increase or a percent of decrease. A percent of increase is when the original amount increases, and a percent of decrease is when the original amount goes down. For both of them, you're going to calculate the change in the amount, divide it by the original amount, and then multiply that by 100 to get the percent of change. Because of the increase and decrease, when you're calculating percent of increase, the larger amount is the new amount, so you would start by using the new amount minus the original amount. And with a percent of decrease, since the new amount is smaller, you would actually start by subtracting the original amount minus the new amount. Let's take a look at an example. This says to find the percent of increase, round to the nearest tenth of a percent if necessary. From 10 inches to 25 inches. Since we're starting with a smaller number and going to a bigger number, I know that it's an increase. We'll subtract 25 minus 10 since 25 is bigger, and then we divide by the original amount, which is 10. This amount, once we get our answer, will be multiplied by 100 just to convert it to an actual percent. So we can plug that into a calculator to solve if we need to, and you should get 150%. Example 2, we have a percent of decrease. So we're starting with 65 people, and then it goes down to 57 people. So in order to calculate the percent of decrease, we find the difference in the amounts first, the larger amount minus the smaller amount. We always divide by the original amount, and then we calculate the percentage by multiplying that by 100. So in this example, you should have gotten a percent of decrease of about 12.3%. To round to the nearest tenths place, remember you look at the tenths place, that's what you're rounding to, but it's the bossy neighbor next door to the right that tells that place what to do. 5 or higher, you would round up. Anything other than that, it would stay the same. Here's a couple of examples for you to try on your own. First, it says to identify the change as an increase or decrease. Then find the percent of change. In the first example for you to try on your own, notice that it starts at 75 people and then it goes down to 25 people. You'll always start by calculating the change in the amount, divide that by the original amount, and then multiply by what you get by 100 to convert it to a percent. The next example starts at 24 songs, goes up to 78 songs. In order to calculate the percent of change, we'll start with the larger amount, subtract the smaller amount, divide that answer by the original amount, and multiply by 100 to calculate the percent. The next couple of examples are a little bit different. It says to find the new amount rather than find the percent of change. So the percent of change is given to us here. It says here 8 meters was increased by 25%. So what we need to do is we need to calculate the actual change. To do that, we start with the amount given, 8 meters. We're going to multiply that by 25% as a decimal, 8 times 0.25. 25 hundredths, or a quarter, of 8 is 2. That only tells us the amount that was increased. So to find the new amount, we would take the original amount, 8 meters, and add the 2 meters that it increased for a total of 10 meters, which would be the new amount. This example is similar, except it's a decrease. The original amount was 50 points, and that decreased by 26%. So we have to calculate the change in the amount, and then we'll subtract that from the original amount to see what the new amount is. Again, we're going to multiply 50 points times 0.26, or 26%. That gives us 13 points. It's a decrease, so from 50 minus 13, the new amount of points would be 37. The other kind of problem that we have in this lesson is called percent error. Percent error is when there's an estimate given and it's not exactly correct. We can determine the percent of error by using this formula. First, we'll find the amount of error by subtracting. We'll divide that by the actual amount, and then of course we again multiply by 100 to convert the answer to a percent. Here's our first example. You estimated that 200 people attended a school concert. The actual attendance was 240. Find the percent error, and then what other estimate gives the same percent error? How do you know? So first, let's look at the information we're given. You estimated that there were 200 people, but the actual amount was 240. First, we need to find the difference. 240 minus 200 is 40. So the difference in the amounts is 40. We divide that amount by the actual amount, which is 240, and then we'll multiply that by 100 to convert it to a percent. Your answer should be approximately 16.7%. The next question says, what other estimate gives you the same percent error? Well, in order for us to plug an amount in, divide by 240, multiply by 100, and still get 16.7, this number has to be the same. 40 has to be the same no matter what. Well, in the example that was given, the estimate 200 was an underestimate. We could still have a difference of 40 with it being an overestimate. So since the actual attendance was 240 people, if we had estimated 40 people over that, 280, that would give us the same amount. I know that it's going to be the exact same amount because 280 minus 240 still gives us 40, and would still divide that by 240 and multiply by 100, which is the exact same calculation I computed the first time to get 16.7%. Let's look at one more example. It says you estimate that the length of your classroom is 16 feet. So the estimate is 16 feet. The actual length is 21 feet. Find the percent error. The first thing we do is calculate the difference between the two. So I know I have to do 21 minus 16. That amount would be divided by the actual amount, 21 feet. And then we'll multiply all of that by 100 to convert to a percent. 21 minus 16 is 5. Divide that by 21 and multiply by 100. Typically with these problems, we'll round to the nearest tenths place. So we would get a percent error of approximately 23.8%. So in today's lesson, you learned how to calculate percent change, whether it be an increase or decrease. And you also learned how to calculate percent error. Hopefully, at this time, you can complete some of these problems on your own.